For in both cases, you have the motor constant given by manifold. Once you know, you can write the transfer function. Next, we will see what we call another type of actuator, because we know that we need two type of motion. One is rotary motion, other one is linear motion. For linear motion, we will be using what we call as hydraulic cylinder or linear electric motor or solenoid. Correct? Solenoid can generate a linear movement or linear force. So in the case of hydraulic system, you call hydraulic cylinder. Hydraulic cylinder, this is the cross section of your hydraulic cylinder. You can see that this is the cylinder, completely enclosed cylinder, both ends are closed, and it has two inlets. They are called in either ports. Right? This is, I can say, port A. I call this as port B. There are two ports through which pressurized fluid can enter and can go out also, both way. So you can show that already shown. In this picture, what is shown is the pressurized fluid, like hydraulic motor, the pressurized fluid, which is pumped by the hydraulic pump. Suction, actually, there's a pump which is driven by motor, which sucks the fluid at 1 bar pressure, pressurized to require this one, and it will be transmitted to the hydraulic cylinder, which is an actuator, through a control valve. Now, we are talking only about the actuator. Next slide we'll see with the control valve also. Now, the pressurized fluid is entering to, say, this is port A, this is port B. It enters here. The bigger high pressure fluid is shown in red color. For example, the P may be, say, 10 bar. It can be anything, correct? And the fluid is flowing at the rate of Q equal to 10 liters per minute. That's a fluid pressure flow rate. Now that enters, since the pressure is there, it exerts a force. This is the force exerted by the fluid due to this pressure. We know that force is proportional to area into pressure. That we are going to see it. So that means the piston, this is the piston, this is the cylinder. Cylinder is completely enclosed. Fluid can enter only through the ports A and B. Now the pressurized fluid is entering to port A, and I call this chamber as chamber A. There are two chambers separated by piston, chamber A, and this is I call as chamber B. Correct? Two chambers, both are filled with fluid. Only thing is difference is pressure of the fluid. What is the pressure of fluid in chamber A? What is the pressure of the chamber B? When the pressurized fluid enters chamber A, it generates a force and makes the piston move from right to left. Like this, it is going to move. From the wherever, whichever position, it will try to move. That means, so automatically, the volume of the chamber B will start reducing because piston is moving like this. Right? As it moves, that means the fluid which is in yellow color shown will be flushed out through port B. It goes to the storage tank, oil storage tank. Okay, the fluid storage tank. Now, instead of that, if I want the motion, in that case, we know that this is the shaft of the piston. Here, I am connecting my load. This is my load. Load having a mass. So the load position is moving from the initial position here. It moves towards A. X of t is the position of the load, which is same as the position of the piston, depending upon the pressure, and also at what rate the piston is moving depends upon flow rate. As I told in this one, hydraulic motor, the flow rate Q decides the velocity of the piston. Automatically, piston moves means auto load velocity, because load is connected here. So load is moving towards this. Instead of that, if I apply the pressurized fluid through this one, it enters here. The fluid will exert. The piston will move from left to right. It will move from left to right. So if that means, depending upon which direction it has to move, port A or B will become inlet or outlet. Correct? When this is inlet, this will become outlet. When this is outlet, this will become inlet. So accordingly, the piston move from left to right or right to left, and at velocity, particular velocity. Okay. So that's what we are showing. Now we can show that the flow rate and the movement are related by the equation in this system. Q is the flow rate given in liter per minute or second or hour, whatever may be, is proportional to A multiplied by d by dt of x of t.